Good afternoon, everybody. Today we will study the determination of aluminium content of deodorants and antiperspirants. So, the aluminium content of deodorants and antiperspirants is determined by using atomic absorption spectroscopy. So, for this purpose, different samples of deodorants and antiperspirants are digested using mixture of acids, and in this case particularly aqua regia is used. And what is aqua regia? Aqua regia is 1:3 mixture of concentrated nitric acid and concentrated hydrochloric acid. So first of all, a requirement. What would be our requirement for determination of aluminium content of deodorants or antiperspirants? We require given sample of deodorant or antiperspirant. Secondly, we require aqua regia, that is 1:3 mixture of concentrated nitric acid and hydrochloric acid. And then we require a standard compound. Standard compound, we can use any of the aluminium salt like aluminium nitrate. Aluminium nitrate, we can use anhydrous aluminium nitrate or aluminium nitrate monohydrate, or we can use aluminium metal for preparing a standard solution of aluminium, and we require distilled water. Next step is preparation of standard solution of aluminium. Now, for the preparation of standard solution of aluminium, as for atomic absorption spectroscopy, the concentrations used are generally in ppm. So we will we need to prepare solutions of aluminium or standard solution of aluminium in ppm. Now, for preparing the ppm solutions, as we know that what is ppm? ppm means parts per million. So what is parts per million? Parts per million means number of parts by weight of a solute dissolved in 1 million parts by weight of the solution. Means if I wish to write 1 ppm, then I can write that would be equal to weight of the solute in grams divided by weight of the solution in grams multiplied by 10 raised to power 6. Now we can write ppm in different ways, and one of the simplest way is if I write 1 milligram per ml. Suppose I dissolve 1 milligram, sorry, not 1 ml. If I dissolve 1 milligram of a compound in 1 liter of water, and now you are familiar with 1 liter. 1 liter is equal to 1000 ml, and 1 gram is equal to 1000 milligram. So if I dissolve a 1 milligram of a solute in 1 liter, then I would say that its concentration would be equal to 1 ppm. Or similarly, I can write that if I am using 1000 milligram, or I am dissolving 1000 milligram in 1 liter, then it would be equal to 1000 ppm. So we can prepare 1000 ppm standard solution of aluminium by using any of the three, either by using aluminium metal, or by using anhydrous aluminium nitrate, or by using aluminium nitrate non-hydrate. So first of all, I will make you clear regarding how to prepare 1000 ppm solution of aluminium using aluminium metal. So for this we require 1 gram or 1000 milligram, because I told you if I dissolve 1 milligram of something in 1 liter, then it would be equal to 1 ppm. So if I dissolve 1000 milligrams in 1 liter, then that would be equal to 1000 ppm. So if I take 1 gram or 1000 milligrams of aluminium metal and prepare its solution in 1 liter, then it would have concentration, it will have concentration equal to 1 ppm. But how we can prepare that? We will dissolve, or we need to dissolve 1 gram or 1000 milligram of aluminium metal in 25 ml of concentrated hydrochloric acid and a few drops of concentrated nitric acid. As aluminium gets dissolved in the mixture of concentrated nitric acid and HCl, then we will make the solution equal to 1 liter by adding rest of distilled water in a measuring 1000 ml measuring flask. Mean we will dissolve the aluminium metal in HCl and nitric acid, and we will add that much of water that is required to make the total volume equal to 1000 ml. So this would be equal to 1000 ppm stock solution of aluminium. Second is by using aluminium nitrate. As aluminium nitrate is having formula AlNO3 thrice, and its molecular weight is 213 grams. So by using its molecular weight, we can also prepare 1000 ppm stock solution of aluminium. So for this, we will need to dissolve 7.899 grams of aluminium nitrate anhydrous in 1 liter of water. This solution will have concentration equal to 1000 ppm. Now, why 7.889 grams in 1000 ml? So we can determine this as, because we know that molecular weight of aluminium nitrate anhydrous is equal to 213 grams. So I can say that if I am having 213 grams of aluminium nitrate, then it will have aluminium equal to 27 grams. So I can write equivalence between them as 27 grams of aluminium will correspond to 213 grams of aluminium nitrate anhydrous. And from this I can write 1 gram of aluminium would be equal to 213 grams divided by 27 grams of aluminium nitrate. So it will come out to be equal to 7.889 grams. So 7.889 grams is the weight of aluminium nitrate which will be having 1 gram of aluminium. So if I dissolve this much weight of aluminium nitrate anhydrous in 1 liter of water, then it will automatically have 1 gram of aluminium or 1000 milligrams of aluminium. So its concentration will come out to be equal to 1000 ppm. So I can say that 7.889 grams of aluminium nitrate will contain aluminium equal to 1 gram or 1000 milligram. So by dissolving 7.889 grams of 1 aluminium nitrate anhydrous in 1 liter of water, we will get the concentration equal to 1000 ppm. Similarly, we can prepare this 1000 ppm solution of aluminium metal by using aluminium nitrate nonahydrate. Aluminium nitrate nonahydrate means 9 water. It is having 9 water. So its formula is AlNO3 thrice 9 water, and its molecular weight comes out to be equal to 375 grams. So for preparing 1000 ppm stock solution of aluminium metal from this salt, we need to dissolve 13.889 grams. More accurately, it would be 13.889 grams of aluminum nitrate nonahydrate in 1 liter of distilled water. So it will be having concentration equal to 1000 ppm. And why 13.889 grams? Because you can calculate this in the similar way as we did in case of aluminum nitrate. But to make more clear to you why we are using 13.889 grams of aluminum nitrate for preparing 1000 ppm solution, I can write molecular weight of aluminum nitrate nonahydrate is equal to 375 grams. So I can say that 375 grams of aluminum nitrate nonahydrate contain 27 grams of aluminium. So I can write that 27 grams of aluminium will correspond to 375 grams of aluminum nitrate nonahydrate. So from this I can calculate 1 gram of aluminium corresponds to 375 upon 27 grams of aluminum nitrate nonahydrate, and this comes out to be equal to 13.889 grams. So if I dissolve 13.889 grams of aluminum nitrate nonahydrate, then it will contain aluminium equal to 1 gram or 1000 milligram. So this solution will be having concentration also equal to 1 ppm. So this is how you can prepare stock solution of aluminium by using any of the three. Then next step is the preparation of solutions of known concentration or other standard solutions or other concentrations like 25 ppm, 50 ppm, 75 ppm, 100 ppm and so on. So you need to prepare other standard solutions whose concentration is known from the 1000 ppm stock solution. So how you can prepare this? For this you need to simply dilute the solutions by using 1000 ppm. You are having stock solution of 1000 ppm. So you can prepare other solutions of any concentration by diluting. For diluting, one way is by using normality equation. Although we are not using normality here, but for dilution purpose you can apply normality equation here. For example, I will give you an example how you can prepare a dilute concentration by using a concentrated concentration. For example, if I want to prepare 50 ml of 100 ppm solution by using 1000 ppm solution. So in order to calculate this, I can write normality equation N1V1 is equal to N2V2. Now what you will need to do, you have to write the solutions on both sides of this equation. This is on the left hand side I have written 1000 ppm because this is known. This is the stock solution, your stock solution. You are having a stock solution of 1000 ppm concentration and you want to prepare solution of 100 ppm. So you will write 100 ppm on the right hand side. So and now what else do you know? You want to prepare 50 ml of 100 ppm solution from 1000 ppm solution. So you don't know that how much volume do you need to prepare, or how much volume of 1000 ppm solution do you need to prepare 50 ml of 100 ppm solution. So that can be calculated by calculating value of V1 from here. So from equation N1 V1 is equal to N2 V2, you can calculate V1 will come out to be equal to N2 V2 upon V1. Now as the norm I told you earlier that here I am not using normality, but as normality is also a way of representing concentration and ppm is also a way of representing concentration. So for the calculation purposes I am using normality equation, but you can put concentrations in ppm. So suppose if I want to prepare 100 ppm solution and its volume you want to make is 50 ml. So I will write N2 equal to 100 ppm say and volume equal to 50 ml, and we are having stock solution of 1000 ppm. So how much volume of 1000 ppm do we require? That would be equal to V1. So V1 will be equal to 100 into 50 upon 1000. So you can see here that 3 zeros in the denominator will cancel out with 3 zeros in the numerator. So V1 will, sorry, this is repetition, I noticed it right now, but I am going to correct it, just the repeated text, or it would be more appropriate to struck it off. I can write it as this. So here this, so this is what I wanted to write here. So you can see that these 3 zeros are cancelling each other with the 2 zeros with 100 and 1 zero with 50 in the numerator. So this volume comes out to be equal to 5 ml. So by using 5 ml of 1000 ppm solution and making the total volume equal to 50 ml in a measuring flask, we will get the 50 ml of 100 ppm solution. Is it clear? Or I can say this in another way. You are using 5 ml of 1000 ppm solution and you are diluting it to 50 ml. Means you are diluting it 5 times. So if you see that by using 1000 ppm, I want to prepare 100 ppm. So it is also 10 times diluted. So it shows that our calculations are correct. So by using this equation, normality equation, you can prepare solutions of other concentrations like 25 ppm, 50 ppm, 75 ppm, or any concentration that you want to prepare. So once you are ready with your these solutions of different concentration, you need to record the absorbances or a second, but before that we will need to prepare sample solution of deodorant or antiperspirant. So for preparing the sample solution of deodorant or antiperspirant, we need to take known volume of deodorant or antiperspirant say equal to 50 ml, and to that we will add aqua regia say 10 ml and followed by 20 ml or known volume of water. Then we will heat this solution on steam bath for about 15 to 20 minutes with occasional stirring, and then we will allow the solution to cool and dilute it to 100 ml with distilled water in a 1000 ml measuring flask by adding rest of water. So this is our preparation of stock solution of deodorant and antiperspirant. So what we are having? We are having standard solutions of aluminium of different concentration like 25 ppm, 75 ppm, 100 ppm, in sequence I would say 25 ppm, 50 ppm, 75 ppm and 100 ppm. And we are having a solution of deodorant or antiperspirant in which we want to determine the aluminium content. So what we will do? Then after that we need to measure their absorbance. So for recording the absorbance, we need to fix the wavelength of the instrument at 309.3 nanometer. So first of all, what we will do, once our instrument is ready for operation, we will set the wavelength at 309.3 nanometer. This is the standard wavelength for aluminium, or I can say that aluminium absorbs at this wavelength. Now what we will do, we will measure the absorbances of different standard solutions of aluminium. What different standard solution that we prepared earlier, that is 25 ppm, 50 ppm, 70 ppm and 100 ppm. So we will record the absorbances of these different concentrations at 309.3. Then after measuring the absorbances, we need to measure the absorbance of the prepared unknown sample solution of deodorant or antiperspirant. Why unknown? Because you don't know in deodorant or antiperspirant how much is the aluminium present. So that is your unknown. Now after recording the absorbances of solutions of different concentrations and as well as unknown, you need to plot a graph between absorbance and concentration. Now please keep in mind that in this case you will take absorbance along y-axis and concentration along x-axis. So this is one graph that I have taken for the purpose of explaining or to make it more clear to you. You can see in this graph, along the y-axis I have represented absorbance. It is the text is little bit blurred, but I have marked it in green rectangle. So green rectangle, in green rectangle absorbance is there along y-axis, and on the basement side, that is along the x-axis, concentration is there. So concentration you can take in any units like grams per liter, but as in case of atomic absorption spectroscopy, the solutions are dilute, so we generally use concentration in ppm. So when we will plot the graph between absorbance of different concentrations of solution, then we will get different points, and by connecting these points we will get a straight line graph. You can see that different points are there along the y-axis, absorbances are there, and along the x-axis concentrations are there. So we are getting a straight line graph by connecting the different points. Now this is a standard graph. Now suppose I recorded the absorbance of 25 ppm solution, 50 ppm, 75 ppm, 100 ppm, and so on, like 200, 400. So I will plot a graph and we will get this sort of graph. And then how we will determine the concentration of aluminium in the sample? We will, as I told you that we earlier recorded the absorbance of deodorant or antiperspirant. Now we will mark that absorbance on the y-axis. Suppose that absorbance comes out to be equal to 0.256. I have written that in the rectangle. Suppose this orange rectangle is showing that the concentration or absorbance of unknown is coming out to be equal to, say, unknown solution of aluminium is come out, deodorant is coming out to equal to 0.256, and its corresponding concentration on the graph is marked in orange oval circle. So then how we will determine its concentration? What we will do, from this point we will extrapolate it onto the x-axis. So when this absorbance 0.256 will cut the straight line, it will cut the straight line at some point, then we will draw a line from this straight line onto the x-axis, where this line will cut, or the point at which this line will cut the x-axis will give you the concentration of the aluminium in the given sample of the deodorant or antiperspirant. Suppose if I am taking this example, in this case the absorbance is coming out to be equal to 0.256 of the unknown sample of deodorant, say, and its corresponding concentration is coming out to be equal to 0.017 from the x-axis. I am not mentioning here the units because I told you this I have taken as an example. You can mention it in ppm, micrograms per liter, or any other units. This picture I have selected just for the purpose of showing you that how to determine the concentration using a graph between absorbance and concentration. So after that, this is what I already made you clear. After plotting the graph, the determination of the concentration in the aluminium in the given sample of deodorant or antiperspirant by extrapolating the absorbance this sample on the graph and then noting down the corresponding concentration from the point of intersection of this absorbance on the concentration axis. This text is all what you made what I made you clear earlier. So this will give you the concentration of aluminium in the given sample of deodorant and antiperspirant. So this is all about how to determine the concentration of aluminium in the given sample of deodorant or antiperspirant. Thank you.